Welcome everyone, hope you're doing well. In this video, I'm going to be going over similar figures. B group especially needs to be watching this video. Hope you enjoyed your snow day yesterday, but that means you won't be able to get this notes in class, okay? So similarity is what this unit is about, unit 6, okay? And today we're going to actually talk about what makes two shapes similar. So two figures are similar. Oh my gosh. Sorry, I left my stylus at school and I have to use this one at home and it's not as good. Okay. Two figures are similar if and only if they have congruent. Okay, I just have to use my finger. All right, they have to have congruent corresponding angles. So what that means is all their angles have to be congruent, all right? And you should be able to match them up, kind of the same way we did when we had congruent shapes, how their angles were the same. Similar figures also have angles that are the same. And that's why, or that's how they keep that shape the same. They also have to have a common ratio between their side lengths. Okay, so we'll talk about what that means more in a second, but that common ratio between their side lengths is called the scale factor. And that's a word that should be familiar to us because we just talked about it with dilations. And that's how dilations connects to similarity, right? It creates similar figures when you do a dilation, okay? And so when two things are similar, you can write what's called a similarity statement. So it's kind of like a congruent statement. So when you write a similarity statement, it looks like this. So you could say like triangle ABC. So this symbol right here, that means similar, all right, the tilde. We could say, triangle ABC is similar to triangle DEF, all right? And it matches everything up the same way that congruent statements do. So angle A and angle D have to be the same, angle B and angle E have to be the same, and angle C and angle F have to be the same, okay? So they tell us here, quadrilateral ABCD is similar to quadrilateral FGHI. Find the following. So it says, what is C? Okay. Well, if we look, C's the third letter in that statement. So we know that C has to match up with angle H. They have to be the same because they're corresponding angles, right? So if we look over here, we know angle H is 80 degrees. So therefore, angle C also has to be 80 degrees. Okay. Similarly, it says, what is J? Well, J is the last letter, so it has to match up with D, which is also the last letter. So if we come over here, all right, D is 100 degrees, so J also has to be 100 degrees. And if you look at these two shapes, you can see where all the angles match up with each other, right? 60 and 60, 120, 120, 100, 100, 80, 80. All right. So that's the first thing. Second thing, what is the scale factor from quadrilateral ABCD to FGHJ? So that means we're going from small to big, okay? So in order to find the scale factor, all right, remember we used to talk about what are you going to multiply by to get from one shape to the next, right? Well, in order to find the scale factor, you have to find two corresponding sides that you have the side lengths for both shapes. So here on the right shape, 15 for GH is the only side that we know its measurement. So we need to find what's the corresponding side for that for ABCD. That would be down there, 9. Okay, so that's the only side where we actually know both side lengths in both figures. So what that means is we have to use those sides to find the scale factor, okay? And so let me just label this real quick. So this is our pre-image, right? And this is our image. In order to find the scale factor, all right, the scale factor is always going to be a pre-image. Oh, wait, that's wrong. Sorry. Don't listen to that. It's always going to be image divided by pre-image. Okay, so the new shape divided by the smaller shape, and that'll find the scale factor. So our image length is 15, and our pre-image is 9. The reason I'm explaining all of this is because it's not really obvious what 9 multiplies by to get to 15, right? It's not going to be a whole number. You know, if instead of 15 it was 18, okay, you know the scale factor is 2, right? Because 18 over 9 equals 2. But we have to do this, so we need to simplify this. Now, you could write it as a fraction or a decimal. This is going to be 5/3, which is otherwise 1.6 repeating. So whichever one of those you want to use, all right, is fine with me. So now it asks us for some side links, right? It's basically asking us for all 3 of these side links over there on the image that we don't have. So it says, what is the side length of GF? Okay, so the way to find the new sides is to multiply your old sides by the scale factor, okay? So GF is this side right here, and that side matches up with AB. And again, you can always tell this by here if you're not sure. AB multiplies up with GF, okay? Or matches up with. So what we're going to do is multiply your pre-image side by the scale factor to get your image, okay? So if our scale factor is 5/3, we need to multiply 5 times 5/3. Now you can use your calculator, but we know fractions you multiply straight across, so 5 times 5 is 25, divided by 3. So this is going to be 8.33. Okay, so that'll be the side length of GF. So what about FJ? Okay, well, FJ, all right, that matches up with AD. So we need to multiply 3 by our scale factor. Now this one's easy to do. If we multiply, our 3's cancel, so we just get 5. All right, so our length of FJ is 5. Lastly, we need to do JH. JH is on the right, so that matches up with 6, okay? So we need to do 6 times 5/3. Again, you can use your calculator, but we can also just multiply straight across here. 6 times 5 is 30. 1 times 3 is 3. 30 divided by 3 is 10. So we know that JH is going to be 10. So I'm kind of explaining this in depth, but hopefully that made sense. You can multiply your scale factor by your first shape, and that'll give you the sides in your second shape, okay? So another example. All right, let's look at another one. So it says quadrilateral DCBA is similar to quadrilateral HGFE, and the scale factor is 2. Find the missing side length. So this one is a little bit easier, right? You should be able to do this one on your own. It says the scale factor is 2. It actually doesn't say a direction, but we can assume that since it's getting bigger, you know, that we can use the scale of the shape. So fill in the missing side length. So HE, all right, HE matches up with DA. Multiply DA by 2. That will be 24. On top, we need to multiply 15 by 2. That'll give us 30. CB multiplied by 2, that's 36. And then on the bottom, since we're going backwards, we don't multiply by our scale factor, we actually divide by our scale factor. So if we do 16 divided by 2, that means this one has to be 8. Okay. So this is more of a typical problem. It's easier when you have a scale factor that's a whole number. Okay. Last questions. Are any of the quadrilaterals similar? Okay. So we're going to look here at some examples. So the first one is, I think, these first two. It says A, B, C, D, and E, F, G, H. So are they similar? Okay. So there's two things that you need to check in order to figure out if something is similar. The first is, are all the angles, or the corresponding angles congruent? So here the answer is yes. They're all right angles. So that we check that box. Is there a common scale factor between all the sides? Well, that we're going to have to say no for that one. So this one's going to be no. The reason is because all of these are 5. So they're all the same. So in order for them to be similar, this one, they all have to be the same. However, we have 4 and we have 2, right? So if we used, 5 to 2, that give us a scale factor of 5 halves. If we used 5 to 4, that would give us a scale factor of 5 fourths. So, therefore we don't have that common ratio between the side things. So that one's going to be no. B, A, B, C, D, and J, K, L, M. All right, so we're looking at this one, our first one, our third one, okay? Again, angles, okay? For angles, it's yes, all right? They all have right angles there, so that one works. And then, is there that common ratio in their sides? Well, here we have all 4 side lengths of 5. Here we have all 4 side lengths of 3. So therefore, yes, all right, these are similar. 5 divided by 3 is 5 thirds. So, the common ratio is always going to be 5 thirds. What about A, B, C, D, and N, O, P, Q? So now we got to look at the first and the fourth. Okay. So again, check the angles. Here we have 4 right angles. Here, though, this is an angle of 88 degrees. That means the corresponding angles aren't congruent. So we don't even need to check the side lengths. This one's already going to be no. Okay. And then it says J, K, L, M, and N, O, P, Q. This one's also going to be no, pretty much for the same exact reason, all right? All of these angles are right angles, and that angle N right there is 88 degrees, so we can already say no, the corresponding angles aren't congruent. So that's kind of how you can check to see if two shapes are similar. So that's the notes for today, all right? Tomorrow, you'll have your practice to do, all right? So give that a shot. If you're having trouble or if you have any questions on these notes, you can come to office hours. All right. Remember, office hours will be from 9 to 11:30. And I'll be more than happy to give you guys some help. So hopefully this made sense, and enjoy the rest of your day.